Assalamu alaikum.
Walaikum assalam, sir. How are you, sir?
Alhamdulillah, fine. And how are you all?
Alhamdulillah, fine, sir.
Do you have any doubt from last class?
No, sir.
I think we are doing center of mass.
Yes,
Salman, any doubt?
No doubt.
Okay. Let me define you the other concept of the center of mass. If some portion is cut out, suppose you have disk like this, from which a small disk is cut out. Let's say this is your disk, which was initially complete disk. Now, a portion of it is cut out or removed out. So we have to find its new center of mass. This portion is removed out. X-axis and Y-axis. So how to define these type of problem? So just use formula. Center of mass for these type of problem will be M total X total minus M removed X removed divide by M total minus M removed. I'm defining you each term. MT is total mass of body without cutout portion. Xt is position of center of mass of whole body. Position of center of mass of total body or whole body. Next is MR, that is mass of removed part. And XR is position of center of mass of removed part. Is it clear? Is it clear to all of you?
Yes, sir.
Okay. Now in this question, we have a circular disk. So let me solve it. As we know, disk is two-dimensional body. So mass distribution will be areal. So if you calculate total mass of body, let's say radius of disk will be this, which will be diameter of this cutout portion. So radius of this smaller disk will be r by 2. So M total equals to sigma times its area, which is pi r square, and m removed equals to sigma pi r by 2 square, so it will be r square by 4. And I had defined you in last class, for all symmetrical body, center of mass would lie at its midpoint or point of intersection of line of symmetry. So just see in this part, x-axis and y-axis is behaving as its diameter, so it will be treated as line of symmetry. So its center of mass would lie at its midpoint, that is origin. So x total, that is position of center of mass of total body, will be at origin. And from that point, center of mass of removed part will be at r by 2. Is it clear?
Yes, sir.
Yes, sir.
Now put these terms in this above formula and simplify it to find the value of x. Try to solve. Hamza, any problem?
Yes, sir, a little, but I'm doing it.
Okay, let me solve. X is equals to m total, which is sigma pi r square times x total, which is 0, minus mr, that is removed part, sigma pi r square by 4, xr is at r by 2, whole divided by mass total, sigma pi r square, minus mass removed, sigma pi r square by 4. So if you simplify it, sigma pi r square times 0, it will be 0, minus sigma pi r square, take it as common, so you're left with r by 8. Whole divided by, take out sigma pi r square as common, so it will be 1 minus 1 by 4. So sigma pi r square by 4, sigma pi r square by 4 will cancel out. So you're left with minus of r by 8 divided by 4 minus 1, it will be 3 by 4. Or minus of r by 8 into 4 by 3. So 4 into 2 will be 8. So finally, it will be minus of r by 6. Khalid, is it clear?
Yes, sir.
Salman, is it clear?
Yes, sir.
Okay. You all have written?
Yes, sir. Done.
Iba, do you have any doubt?
No, sir.
Now, the next concept is about forces. So let me define you force. We may divide force in two different parts. First is internal force and second is external force. Suppose there is a car front seat, and individual from back is applying force to this particular front seat. And second part, another individual at this point is applying force to this car. So in which case car will move or likely to move? in first case or second case? Hiba? If man is strong enough or capable of just slide or shift. Yes, Hiba, tell me, in which case it will be get slightly displaced? In first case or second case?
The second one.
Salman?
External.
Why not internal? Khalid?
Yes, sir.
Why not internal force?
Sir, the force is only applied on the seat.
Okay. Whether you apply on seat or back of it, it will be remain same. Let me define you. In first case,
Not touching the ground.
okay, let's say in first case, if individual is applying force to this car, let's say along this direction, his feet is attached with car itself, so there will be a reaction force along this direction. So both action and reaction applied on the same system, that is car. So these two actions and reaction will cancel out each other. So there will be no resultant impact of this force. Or you'll say these two pair will cancel out each other. But in second example, individual is applying force to this car. So this will be action and reaction will be on the ground in opposite direction. And since these two terms are different bodies, or you'll say action and reaction are applied on two different bodies, so they will never cancel out each other. That's why only external force will be responsible for bringing any change to any object. Is it clear?
Yes, sir.
So we can conclude only external force will be responsible for changing position of center of mass or velocity or acceleration of body. Only external force will bring out any change in position of center of mass. So for internal force, net shift in position of center of mass will be 0. So for internal force, shift in position of center of mass will always be 0. Hamza, is it clear?
Yes, sir.
Now there is some relation to find amount of shift. As we had formula, x center of mass equals to m1 x1 plus m2 x2 divided by m1 plus m2. So using this, you may write delta x shift in center of mass equals to m1 delta x1 plus m2 delta x2 divided by m1 plus m2. And since for internal force, delta x shift should be 0, therefore you can write m1 delta x1 plus m2 delta x2 is equals to 0. Khalid, is it clear?
Yes, sir.
Okay, just write it down. I'm coming in just 2 minutes, okay? Okay, you all have written?
Yes, sir.
Let me give you some problem related to this. This is Bank of River. A boat and there is individual on it having mass 60 kg and mass of both is 40 kg. Position of boat from this end is 10 meter and length of boat is 4 meter. This is A and this is end B. If man goes from A to B, find position of man from shore or bank of river. Now let me define you how to approach these type of problem. So first, try to analyze, is there any external force acting on this man and this boat system? Hamza, is there any external force acting on man or boat system?
No, sir.
Okay, so you'll say, no, there is no external force. So if man goes from A to B, this will be your action. In return, boat will slightly shift towards right in reaction so that position of center of mass will remain at its own position. So just use, since in this part there is no external force, so shift in center of mass will be 0. So m1 delta x1 plus m2 delta x2 equals to 0. Now how to use this formula? Let's say m1 is mass of man, which is 60 kg, and is going from A to B, which is an opposite direction, or take it as negative x-axis. Total length from A to B is 4 meter, so it will be -4. Is it clear?
Yes, sir.
Salman, any doubt?
No, sir.
Now, boat will slightly shift towards right. Whether boat alone will move towards right or it will move with the whole system combined with man. Khalid, tell me whether boat alone will shift from its own position towards right or it will slightly shift man also with it. So you will say, since man is a part of system of that particular boat, so if boat is shifting towards right, so man will slightly shift along with it. So the total mass affected in this case will be mass of boat plus mass of man, both. Is it clear? Hamza, is it clear?
Yes, sir.
Times delta x2 equals to 0. So first try to find delta x2 from this equation. Try to solve.
Sir, can you explain once more M1? I'm still not getting quite.
Okay. Suppose if man will move from its own position, let's say A, towards B,
Okay.
is there any other mass be affected while going of man from A to B? So you will say no, he will move individually from A to B. Now, due to this action, as net shift and center of mass will be 0. So both will shift towards right. And since man is a part of system of board, so along with board, man will itself slightly get shifted towards right. Is it clear?
Yes, but how -4? That's what I'm asking.
I have taken coordinate system,
Oh, okay.
this to be positive x-axis and this to be negative x-axis. So man is going from A to B, total length is 4. It is towards negative x-axis. That's why I have taken -4.
Yeah, okay, I understand.
Okay.
Cartesian plane, okay.
Calculate delta x2 from this part. So if you simplify it, you'll get 6 into 4, it will be -240 plus 40 plus 60 is 100 times delta x2 equals to 0. Move this -240 to the other side. So 100 delta x2 equals to 240. So delta x2 equals to 240 by 100, that is 2.4 meter. Hamza, is it clear?
Yes, sir.
So we have to find position of man from end. So it will be since man has moved from point A to B and the distance of B from end is 10 meter, but boat now gets shifted 2.4 meter back to its right side. So the total distance now will be 10 plus 2.4 meter. That will be 12.4 meter. Is it clear?
Yes, sir.
Khalid, any doubt?
No, sir.
Okay. You all have written?
Yes, sir.
Okay. So this is all about position of center of mass or calculation of position of center of mass. Next, we have to define velocity acceleration using this position. So as we had R, position of center of mass, M1 R1 plus M2 R2 plus so on to Mn Rn divided by total mass, that is M1 plus M2 and so on to Mn. Now, if you differentiate it, you will get velocity. So velocity of center of mass will be M1 V1 M2 V2 plus so on to Mn Vn whole divided by M1 plus M2 plus so on to Mn. If you move all the masses towards right, towards left, you will get net center of mass about, or net linear momentum about center of mass equals to P1, P2 plus so on to Pm. So instead of taking sum of individual momentum of individual particle, if you take momentum about center of mass, it will be equals to total momentum about each individual particle. That's why we define center of mass instead of taking this whole as sum. Is it clear?
Yes, sir.
Now, if you further differentiate velocity, you will get acceleration of center of mass. So it will be m1a1 plus m2a2 plus so on to mn divided by total mass m1 plus m2 plus so on to mn. Now, if you move all masses towards left, you will get total mass into acceleration as total force about center of mass. So it should be equals to F1 plus F2 plus so on to Fn. Is it clear?
Yes, sir.
You all have written?
Yes, sir.
Salman,
Yes, sir.
you have written?
Yeah.
Okay. So this is all about center of mass, position, velocity, and acceleration. So you have to use only these formula to define velocity, center of mass, acceleration of center of mass, and position of center of mass. Now the next topic of this chapter is moment of inertia. Suppose we have two types of motion. One is called translational motion, and second is rotational or circular motion. So for translational motion, if you have a body having mass m, so if you apply force on it, there is tendency of body due to which it will oppose external force so as to continue their own state, which is called as inertia in translational motion. Is it clear?
Yes,
So
sir.
inertia is nothing but in translational motion, the tendency of a body due to which it opposes external force so as to continue their own state. So in translational motion, the tendency of body to oppose external force so as to continue their own state is called inertia. Similarly, in rotational motion, suppose there is a body which is revolving along circular path around given axis. At some fixed distance like this along this path. So force in terms of a rotational term, it will be termed as torque, or you'll say the impact of force which causes turning effect is called torque. I will define you later in detail about torque, but still this part, just remember torque is rotational effect of force, or in rotation, the analogy of force is torque. Is it clear?
Yes, sir.
Yes, sir.
So you will say in rotational motion, the tendency of body which resist or oppose torque acting on it so that it will continue their own state. Then this behavior of body in terms of rotation is called moment of inertia. Is it clear?
Yes, sir.
So in rotational motion, the tendency of body to oppose external torque so as to continue their own state. Is called moment of inertia. So you may define moment of inertia is a rotational analog of inertia in translational motion. Is it clear?
Yes, sir.
Okay, just write it down.
Done, sir.
Salman, you have written?
Wait a second, sir.
Okay.
Okay, sir, done.
Now the first formula for this moment of inertia, I will not derive it since you don't have to use it or derivation it. You have to use only formula. So first is moment of inertia for discrete particle system. Suppose this is axis of rotation from which number of particles are connected having different length like this. And this whole system is rotated about this axis. Let's say M1 having distance R1, M2 at distance R2, and so on to Mn at distance Rn. So moment of inertia of this whole system about this axis of rotation will be I equals to M1 R1 square, M2 R2 square, plus so on to Mn Rn square. So this will be a formula for calculation of moment of inertia for discrete particle system, means a system having a number of particles separated at some specific distance from axis of rotation. Is it clear? So in this part, R is perpendicular distance of point mass from axis. So we can define its unit. So SI unit is kg meter square. Is it clear? Khalid,
Yes,
is
sir.
it clear? Okay, just write it down.
Done, sir.
Find moment of inertia. From this given axis, which is passing through this point, so that this whole system would tend to rotate along this axis. Mass of each block is m, and this is equilateral triangle having side L. So for any problem, first try to define position of each block or each particle from axis of rotation. Let's say this particular since it is at origin, so its perpendicular distance from origin will be 0, mass m2 m, and its perpendicular distance from axis is L. Mass m3 is m, and its perpendicular distance from axis, it will be this. This particular length is L, and this angle will be 30 degree. So this will be x coordinate. So sine of 30 equals to perpendicular over hypotenuse using this triangle. So x will be L times sine 30, which is 1 by 2. So R3 equals to L by 2. Is it clear?
Yes, sir.
Now put these formula in this above term to find moment of inertia about this given axis. So I will be m1 r1 square, m2 r2 square, and m3 r3 square. Put all the values in this part. Salman, just check your calculation. M1 is M, R1 is 0, M2 is M, R2 is L square, M3 is M, and R3 is L by 2 square. So this term will be 0, this term will be ml square, and this term will be ml square by 4. So 4 plus 1, it will become 5 by 4 ml square. Okay, Hamza?
Yes, sir.
Khalid, is it clear?
Yes, sir.
Similarly, in this part, if you have to find moment of inertia, let's say along this axis or along x-axis. So from this axis, R1 will be 0 since it is at origin, and R2 will also be 0. It is again at this axis, and R3 will be perpendicular separation from this. Let's say this is Y. So this angle will be 60 degree. So sine 60 equals to perpendicular over hypotenuse. So Y will be root 3 times of L by 2. So in this term, R3 equals to root 3 L by 2. So moment of inertia for this axis will be M1 R1 square, M2 R2 square, M3 R3 square. This term will be 0. M3 is M, R3 is root 3L by 2. On squaring, it will be 3 by 4 L square. So you'll get 3 by 4 ml square. Is it clear?
Yes, sir.
Hamza, is it clear?
Yes, sir.
So from this, we can conclude moment of inertia would depend upon axis of rotation. If you change the axis of rotation, it will change its value. Salman, do you have any doubt?
No, sir.
Okay. So this was moment of inertia with respect to y-axis, and this is moment of inertia with x-axis. You all have written?
Yes, sir. Done.
Now, there will be some factor on which moment of inertia will depend. Factors affecting moment of inertia. First is distribution of mass. Suppose you have convex lens and you have concave lens. Having same mass and having same length. So which one do you think will have more moment of inertia, convex or concave? Khalid,
Yes, sir.
which one do you think will have more moment of inertia, concave
Sir,
or convex?
concave.
Okay. Hamza, any
Sir,
guess?
the concave.
Okay. Suppose if you define distribution of mass from axis of rotation for this convex part, so it will be like this. So as we go from axis of rotation to its end, mass is decreasing. But in this concave part, as we go from axis to end, mass is increasing. So greater the mass distributed at its end, it will have more moment of inertia. That's why moment of inertia of a concave lens is greater than moment of inertia for convex lens. So just remember, greater the mass distributed at its end, it will have more moment of inertia. Next is position of axis. Position of axis of rotation. Suppose you have convex lens and you have placed axis first at this point and at this point. In which case, moment of inertia will be in larger or more? First case or second case? Hiba, just use the above concept of distribution of mass and try to define in which case you will get more moment of inertia.
The second one.
Good. The larger the length of the distribution of mass from the axis of rotation, it will have more moment of inertia. So in the second case, you'll get more moment of inertia as compared to first case. Similarly, third term is orientation of axis of rotation, which means suppose you have lens like this and axis of rotation is this, and second case axis of rotation is like this. So in which case do you feel it will have more moment of inertia, first or second? Salman?
The first one.
Good. First one. So moment of inertia basically depends upon these three factors. Just write it down. You all have written.
Yes, sir.
Khalid, you have written.
Yes, sir. Done.
Okay. Now, the next term is moment of inertia for continuous body. Moment of inertia for continuous body. As we have moment of inertia equals to m1 r1 square plus so on to mn rn square. So we may write it as mi ri square summation. And for small segment, this summation will transform to sign of integration. R will define its position and mass will convert into dm. So this will be our formula for uniform or continuous body. Now, we have to apply this formula to calculate moment of inertia of continuous body. Suppose if you have to calculate moment of inertia of uniform rod about its center of mass. Suppose this is any rod which having mass m and length l, which is placed along x-axis, and axis is about, or axis of rotation is about center of mass perpendicular to it. So for any continuous body, we have to first take a small strip. So let's say at this point, having mass dm and its width dx, its position from axis of rotation is x. And now this x will extend from one end, that is minus L by 2, to the other end, that is plus L by 2. Is it clear? Or do you have any doubt? Hamza, is it clear?
Yes, sir.
Since we have to apply moment of inertia I equals to r square dm, which is formula for continuous body. That's why I have taken small strip dm having width dx. In center of mass, I define you distribution of mass. So for length, it will be lambda For area, it will be sigma, and for volume, it will be rho. Since rod is a linear dimensional body, so lambda will be equals to total mass by total length, small mass over small length. So from this, dm will be mass times length into dx. Put this value in this part, you will get integration dm is m by l times dx, and r is position of dm. In this part, it is x. So it will be x square dx. M and L is constant, so take it outside. Integration x square times dx. And now, since x is going from minus of L by 2 to plus L by 2, so it will define its limit. Khalid, is it clear?
Yes, sir.
Okay, just write it down and try to integrate this term and simplify it. Salman, you have to simplify it. Just integrate it and put the limit and simplify it. X to the power n dx on integration will be x to the power n plus 1 divided by n plus 1. Just use this formula and try to integrate, then put the limit and simplify it. m divided by L, we have x raised to the power 2. So if you integrate it, you'll get x raised to the power 3 divided by 3, limit from minus L by 2 to plus L by 2. Take 3 to be constant and take it outside. So you're left with m by 3L x cube. So just put upper limit q minus lower limit q. On simplifying, you will get m by 3 times L. It will be L cube by 8 minus minus plus L cube by 8. So L cube by 8 will be 2L cube by 8, which means L cube by 4. And if you further simplify it, this L and this L cube will cancel out. So you will get ml squared divided by 12. So this will be your moment of inertia of a rod about its center of mass. Is it clear?
Yes, sir.
Khalid, is it clear?
Yes, sir.
Okay. You all have written?
Yes, sir.
Salman,
Yes, sir.
you have written?
Yes, sir.
Now, I'm defining you moment of inertia of different object, which you have to remember. Moment of inertia of rigid body. First is rod, which I had calculated from its center of mass. circular ring, another circular disk, this axis is along z-axis, so moment of inertia will be defined along z-axis. So Iz will be mass of object times r square, where r will be radius of this circular ring. For disk about this given axis, it will be m times r square divided by 2. Next is a cylinder. And let's say one of axis is along this direction and the other is along this direction. So if you observe this axis, it will seem to be ring-like structure. From this, it means moment of inertia about this axis will also be like ring. From this axis, let's say along z-axis, this will act like a rod and passing through diameter of the circular ring. So total moment of inertia from this point will be ml square by 12 due to behaving like a rod plus m times r square by 2 due to passing through its diameter. Is it clear?
Yes, sir.
Next is a solid cylinder. So if you observe along this axis, it will seem to be disc-like. So moment of inertia would be similar to disk, mr square by 2. And from this axis, it will be along midpoint of a rod and also along diameter of disk. So total moment of inertia will be m times L square by 12 plus m times R square by 4. Hamza, is it clear?
Yes, sir.
Okay, just write it down. You all have written?
Last one, sir.
Okay.
Done, sir.
In all of these 4 different cases, z-axis is also axis along its center of mass. So you have to remember moment of inertia of a particular object about center of mass. And for calculation of rest of any position, I will define you 2 different theorem. Okay. Salman, you have written?
Yes, sir, done.
Okay. Next is hollow sphere. Solid sphere. So moment of inertia about z for hollow sphere, it will be 2 by 3 times mr square. And for solid sphere, it will be 2 by 5 times mr square. Just write it down.
Done, sir.
Hiba, you have written?
Yes, sir.
Now, to calculate moment of inertia for any axis other than the center of mass, we use 2 different theorems. So first is theorem of perpendicular axis or perpendicular axis theorem. Suppose you have any object like this or a 2-dimensional body. In physics, it is called as lamina. Now, there will be 2 different axes. This is x-axis. Let's say this is x-axis. And this is y-axis. and this is z-axis. Is it clear?
Yes.
So in this part, object is in xy plane. So z-axis will be perpendicular to it. So according to perpendicular axis theorem, Iz will be equals to Ix plus Iy. Is it clear?
Yes, sir.
So whenever you have a body which is lying along any plane, whether it will be in xy plane, yz plane, or zx plane, the moment of inertia perpendicular to that plane will be equals to sum of moment of inertia about the two axes which is lying along the plane of body. Okay. Just write it down. I'm defining using an example. You have written.
Yes, sir.
Khalid, any doubt?
No, sir.
Suppose you have to find moment of inertia of a ring about its diameter. Moment of inertia of a ring about its diameter. So let's say this is circular ring for which you can define one of its diameter along this direction and the other along this. So this will be x-axis, which is diametrical axis. This is y-axis, which is also diametrical axis. And z-axis will be perpendicular to it. So it will be along this direction. Is it clear?
Yes, sir.
So how we can apply moment of inertia perpendicular axis theorem using these three different axes? First, try to define along which plane body is in or body is lying. So in this part, a ring is lying along xy plane, which means z-axis is perpendicular to it. So according to perpendicular axis theorem, Iz will be equals to Ix plus Iy. Is it clear, Hiba?
Yes, sir.
Now we have value for Iz, which is about center of mass. So it will be mr square. Ix is diametrical in, so we can write it as id. Iy is also diametrical in, so it will be also id. id and id, it will become 2id. So I diametrical is equals to I divided by 2. It means moment of inertia about diametrical end will be half of moment of inertia about its perpendicular axis passing through its center. Is it clear?
Yes, sir.
Due to this, I have written above for this cylindrical part mr square by 2, since this axis is passing through its center or its diameter. And for its disk part, moment of inertia will be mr square by 4, that is half of Iz. Is it clear?
Yes, sir.
Okay, just write it down. Khalid, any confusion?
No, sir.
Okay.
Sir, what is ID, by the way? Again,
Moment of inertia about its diameter.
okay, sir.
Since x-axis is passing through its center, so the line which is passing through its center must be diameter. So x-axis and y-axis here is behaving as diameter. You all have written?
Yes, sir. Done.
Salman, any doubt?
No, sir. Finish right.
Okay. Now the next theorem related to this moment of inertia is theorem of parallel axis. Or parallel axis theorem. Suppose you have a lamina or a two-dimensional body which is lying along xy plane. So first, there should be an axis passing through its center of mass. Let's say this point is center of mass and axis through its center of mass is this term. So this will be moment of inertia about center of mass. Is it clear?
Yes.
I have assumed a lamina or a two-dimensional body, and from its center of mass, there is an axis about which moment of inertia is IC. Now, draw an axis parallel to it along its plane in any direction. Let it be at this. Separation between two axes is H, and these two axes must be parallel to each other. So according to parallel axis theorem, moment of inertia about this axis equals to moment of inertia about center of mass plus total mass of object times square of separation between them. So this will be theorem of parallel axis. So there is only one condition in this. First, IC must be parallel to IP, separated at some distance h. And IC will be moment of inertia about its center of mass. Khalid, is it clear?
Yes, sir.
Okay. Let me define you an example related to this. Just write it down. IP is moment of inertia about parallel axis.
Done, sir.
Suppose you have to find moment of inertia of rod from its one end. This is rod and axis is about its one end. So it will be about this, which we have to find. Now try to define an axis about its center of mass. So it will be along this. So this will be moment of inertia about center of mass. Is it clear? Hamza?
Yes, sir.
We have calculated initially about center of mass. So moment of inertia about center of mass of rod is ml square by 12. And we have to find moment of inertia about this axis, about its one end, let's say E. So we have to define first separation between two axes. Since IC is at midpoint, so separation between two axes must be L by 2. Is it clear?
Yes, sir.
Now put these two values in above formula for parallel axis theorem and simplify it. Try to solve. Just put the values of IC and H and simplify it. Khalid, you have solved?
Yes, sir.
Tell me your answer.
Final answer I got ml square by 3.
Good. So if you put the value of H to be L by 2, on squaring, it will become L square by 4. Now take LCM to be 12. So it will be ml square, 3 times of ml square. So it will be 4 ml square by 12 or ml square by 3. Is it clear, Iba?
Yes, sir.
Salman, is it clear?
Yes, sir. I got the same answer. There I
Okay.
can put by 3 in the answer.
Okay. So this is all about calculation of moment of inertia and different theorem. So just stop here. In next class, I will define you about torque, angular momentum, rolling motion. Okay?
Okay, sir.
Okay then. Take care. Allah Hafiz.
Thank you, sir. Allah Hafiz.
Sir, Allah Hafiz.
Sir, there was a special class, right? Like tomorrow for me, something, I guess.
For you,
Yeah, something at 5:30 or something. No, yeah, 8:30 tomorrow.
I don't know about.
Oh, okay. I was gonna ask
Of
what.
which chapter?
No, like they said for me, especially extra classes they will take.
Okay, okay.
I thought you were taking. Okay, fine.
No, I'm not taking. Some other tutor will take your class.
Oh, okay. Okay.
I think they will revise or take revision class depending upon
Yeah.
your doubt. Okay?
Yeah. I'm
Okay.
sure